Unit 2, Lesson 7, Radical Ideas. In our jumpstart here, we have 3 properties listed, and it says illustrate rules for the radicals with an example. So let's take the first one. So this says that basically when you match the index of the root, so say I have a 3 here in the index position of the root, and then I go ahead and take a number or a variable to that number, to that power, they cancel each other out. And you just get the original back. The second one says that if I have 2 things inside of a radical, let's say that I've got 27x to the third, and I take the cube root of that, that's the same thing as taking the cube root of the number and also the cube root of the variable. And the last one is very similar. It's just a fraction. So an example of that could be, let's say we put 2 numbers in those positions. The cube root of the fraction 27/8 is the same as taking the cube root of 27 and dividing that by the cube root of 8. And the cube root of 27 is 3, and the cube root of 8 is 2. And then why are they true? By writing the radical expressions using rational exponents. So we're just going to translate those. Excuse me, the first one, the cube root, change it to a 1/3 power, and then you're taking 3 times a third is x to the 1, or just x. 27x to the third to the 1/3 power. There's a power rule that says you get to move that power in on both of them. Just like this. And I'll put parentheses around that one. Actually, that would simplify to 3x completely. And the last one would be the same idea. It would be taking 27/8 to the 1/3 power and then giving each of them that 1/3 power. So roots and exponents share the same rules or the same properties. All right, let's move in now to the launch, explore, and discuss. It says, now that Tia and Tehani know that a to the m over n equals the nth root of a taken to the m power, they're wondering which form, radical form or exponential form, is best to use when working with numeric and algebraic radical expressions. Tia says she prefers radicals since she understands the following properties for radicals. And there's not too many to remember. Those are the ones we just reviewed. Tehani says she prefers exponents since she understands the following properties for exponents. There are these. So right now, a total of 6. Both Tia and Tehani agree it's important to understand the following rule that expresses the relationship between radicals and exponents. In other words, the connection between the two. And that is that by taking something to a fractional power, you are taking it to a certain root. And here's sort of the general form right here. This would be the number one to remember right here. So if you could put a star or something next to that, that's the important one. Using their preferred notation, Tia might rewrite the cube root of x to the 8th as follows. So she breaks 8 into 3, 3, and 2. She can take the cube root of x to the 3rd and turn it into an x. She can take another one and do it as an x again. So she's taken out 2 whole factors of x. And she has 2 left inside. So basically, the cube root means that we can pull things out in groups of 3. And Tehani points out that Tia also used some exponent rules in their work. On the other hand, Tehani might rewrite the cube root of x to the 8th as follows. He says, I'm going to turn that into x to the 8 over 3. And I'm going to think of that as like a mixed number, 2 and 2/3 with a literal plus sign between them. And there's our x to the 2nd that we had before over here. And then you have x to the 2/3 can be translated back to its root form if necessary. Okay, so for each of the following problems, we're going to change the form of the expression in ways you think that each person might do it. So here's the expression, square root of 27. So Tia's method would be, let's think of all the factors of 27. That would be 3 times 3 times 3. And we're going to do the square root, right? But every time we see 2 3s, we get to take that out. So these 2 are going to come out together, leaving an extra radical 3 behind. And those 2 3s at the beginning are going to just be 1 3 without the radical. So 3 root 3. Tehani, though, would do it with fractions. That would be 3 to the 3rd to the 1/2 power. Or in other words, 3 to the 3 over 2. And then as a mixed number, that would be 3 and 1 plus 1/2. So see, 3 to the 1 is going to just come out as 3. And then 3 to the 1/2 could be written as 3 with the root symbol and 3. So these 2 are equivalent to each other. Cube root of 32. Tia's method would be, 32 broken all the way down into factors is 2 to the 5th. So 2, and by the way, we are grouping them by 3s. So 2, 2, 2, there's a group of 3. And then we're going to have 2 more 3s. 2 more 2s. Now, we'll put the root on. Okay, so those 3 2s are going to turn into a regular 2. And these 2 2s are going to be in the cube root. So the first part right here is a regular 3. And then the second part is going to be 2 times 2. It's 4. And that would be simplified. Tehani would go, no, it's 2 to the 5th power. And that's taken to the 1/3 power. As a mixed number, 2 and 5/3 could be written as 2 and 1 plus 2/3. 2 to the 1 is the 2, and 2 to the 2/3 as a root could be, here's the 2, and then the cube root of 2 times 2 is 4. This one is equivalent to this one. Okay, now we're getting into just having the variable x. Root 20. Root 20 is 4 times 5. Okay, so the square root of 4 times the square root of 5, and then x to the 7th. Now remember, we're breaking it up as groups of 2. So that would be the square root of x squared. There's 2. Another x squared. There's 4. Another x squared. There's 6. And then one more x is 7. See, this is x to the 7th originally. Count them up. 2, 4, 6, and one more makes 7. Now each square root of x squared turns into simply x. Okay, and don't forget out front the numbers. The square root of 4 is 2. And that'll be joined on the outside with 1, 2, 3 x's. So x to the 3rd power. And inside the root, there's going to be this 5 and also an extra x right there. So this is the simplification using roots. Tehani would say that this is 2 squared to the 1/2 power. 2 squared is 4. 5 to the 1/2 power. X to the 7th to the 1/2 power. Okay, now just piece at a time. 2 squared to the 1/2. That's 2 times a half, or just 2. Because this right here, this is equal to 1. See, that's why it's 2 to the 1. And then you have 5 to the 1/2. And 7 to the 1/2 is 7 halves. And that as a mixed number would be 3 and a half. Okay, so stay with me here. There's 2, there's x to the 3rd, and then an extra x to the 1/2. So there's 2 x to the 3rd, 5 to the 1/2, x to the 1/2. Or, in the root form, 2x to the 3rd times the square root of 5x. So remember, taking something to the 1/2 power is the same as exchanging it for the root. So far, so good. If that just doesn't make sense at this point, maybe watch it again or wait until we do a few more examples. All right, now we're talking about a cube root. We've got fractions all over the place. Tia's method, let's see, what would she do with exponent rules? Remember back here, we said that Tehani prefers exponent rules, and Tia prefers radicals. So, right back here, Tia is thinking probably in terms of, okay, if I have 16, that's 2 to the 4th power. So the cube root of 2, 2, 2, and then an extra cube root of 2. Then she's got the cube root of x, and then y to the 5th would be the cube root of y, 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 and then another cube root of y and y. So she's going to be able to take this and turn it into a regular 2, and this and turn it into a regular y, and then she's going to have everything else in a root. But remember, this is all inside of a fraction. with x to the 7th. So x to the 7th is going to have 3 x's, and let's take a root, and another 3 x's, and take a root, and an extra x. That's a cube root. And then those y's, they're not going to be able to go anywhere. So there's 2 y's here. All right, now take a look at what we've got. Here's the simplification. Here's a simplification. But did you notice that there's a couple of spots where we can actually reduce? This one right here, this one right here, this one right here, this one right here. So we're going to be able to cross this one out with this one out with this one. Remember, crossing out, they don't just poof disappear. They get replaced with a 1. Okay, and then the cube root of 2 is going to be a regular 2. The cube root of y is going to be a regular y. And an extra cube root of 2 all over 3 x's turn into 1x. 3 more x's turn into another x, and we can put that as a squared. And that's about it. That is the radical form of the simplification. So, whose method is going to be easier, do you think? Well, I'm going to put my money on Tehani. I think his method's going to be far easier, because he's going to take everything to the 1/3 power. So, in fact, since he likes to do rules of exponents, he can take this inside expression and simplify it a little bit. So, for example, the x's, there's 1 on top, there's 7 on the bottom. That means that we can cancel out 1 on top and have 6 on the bottom. And similarly for the y's, there's 5 on top, 2 on the bottom. So we can cancel that out and make it y to the 3rd on the top. So 16 is still going to be 2 to the 4th power, and that's going to be to the 1/3. And then x's will end up on the bottom. There'll be 6 on the bottom, and that'll be to the 1/3. And then y's, there'll be 3 on top, and that'll be to the 1/3. So look at all this I can accomplish in one step. 2 to the 4th, or 2 to the 4/3, is going to be 2 to the 1 plus 1/3. And then the y's, 3rd to 3rd power, 1/3, that's going to be 1. So that'll just be a y. And let's see, did I forget anything? No, I think I'm good. And then x to the 6 to the 1/3, 6 over 3 is going to be 2, and that's x squared. So you see, all I've got to do is take that 2 that has the 3rd, and so 2y and another 2 to the 1/3. I'm just writing it at the end so that I can show you it's in the same order as this one right here. The only difference between those two is how you express the 2. Either the cube root of 2 or 2 to the 1/3 power. Whew, that's a lot. I definitely think that's a lot. So it's time to pause and reflect here for the second. So one of the conventions in math world is to rewrite expressions so they do not have negative exponents. One of the easiest ways to get started is to rewrite the negative exponents as positive. Notice that in the first step. But you can work with each expression in the way you choose. In each step, write a justification for the step. Here's an example of one that's entirely worked out. So they took that -3 and they brought it up to the top to be +3. Then they did the exponent rule, and finally they wrote the answer. So that would be definitely a good way to attack a problem. So I'm not going to do all of these. This is a lot here, but let's do maybe number 7. So let's make the b's positive first of all. So a to the second, a to the third, but then the b to the negative 3, I'm going to write it on the bottom as b to the positive 3, and then b to the negative 1, I'll write that as b to the positive 1, or just b on top. Okay, so rewrite with positive exponents, and then exponent rules. If there's more a's on the bottom, then the answer is going to stay on the bottom. So a to the third, that'll be a to the 3 minus 2. Just end up with a on the bottom. B to the 3 on the bottom with b to the 1 on top. That would be b to the second on the bottom. Well, what happens to the top? It's a 1. And that's my answer right there. Okay, so some more examples of much more complicated things. But for now, let's look at our takeaways. Okay. So ways to rewrite. Okay, so what we can do is we can write the expression under the radical in terms of prime factorization. So prime factors is a strategy, and look for groups. In fact, if it's the nth root, look for groups of n. So we want to factor the expression under the root sign into products that are squares. We want to factor cube root signs with cubes. So in other words, we want to group them. And rewrite radical expressions with exponents. That means we multiply the exponents by 1 over n. So remember, an nth root will translate to taking something to the 1 over n power. And as far as strategies for changing the form of exponential expressions, the next part, change your negative exponents to positive exponents. Usually involves going across the fraction bar. And also, if you have any powers, 2 powers, go ahead and multiply those. So if you have a power inside to another power outside, then that's whatever to the nm power. All right, I know that's a lot. That's it for now. See you next time.